we are going to be using the determinant method, what we call the determinant method. There are two methods, okay? There are different methods. We have the Cramer's rule and other methods too. But here, we'll be using the determinant method. Now, what we'll do here is to separate each of the numbers, okay? We'll separate it. Now, we are going to extract the numbers from the equation. All right, this is how we are going to put it. There are three matrices here. So we are going to write it in this manner. First, we extract 2. Here, we extract 1. So this is what we are going to have. Here, we have -1. Here, we have -3. Right? Here is -1, and here is -3. So we plot it like this. Okay, and here we have x, and here we have y. Then we plot it like this. Then here we have our 1. Okay, we have our 1, and we have our -2. So this is how we are going to arrange our numbers. You can see that we have extracted the coefficients and all the numbers and separated it from x and y. Now, this is how we are going to do. We are going to find the determinant of this matrix first. This is the main matrix. Okay, we call it the main matrix. So we denote it with delta, delta. Okay, this is delta, which represents determinant. So we are going to use the matrix delta is equals to 2, 1, -1, and -3. So this is delta. Please take note of the difference between this line and these ones. These ones represent brackets, while this line represents determinants. Okay? And then what it means is that we are going to cross these two, right? So 2 times -3, 2 times -3, or you can simply write 2, this is 2 times -3, then minus, right? Remember I said whenever we are cross multiplying, okay, whenever we are multiplying across, there must be minus here. Then we have 1 times -1. So 1 times -1. So this is the main determinant. And when we do this, our answer is going to be 2 times 3 is 6. This is minus. So we are going to place our minus here. Then here, minus times minus is plus. Okay, that's plus 1, because 1 times 1 is 1. Right? So what it means is that, okay, let me put it here. Here. So here is -6 and plus 1 as usual. Okay, then when we evaluate this, this is -6 and this is +1. So we are going to have minus here. I'm sure we know why we are having minus here. Okay, because the bigger number is carrying minus. So which means the final answer we have minus. Okay, but if the bigger one is carrying plus, then the final answer we have plus. That's mathematics. Okay, then the difference between 1 and -6 is 5. So we're going to put 5 here. Okay, once you have given the bigger number here, the sign of the bigger number here, just take take the difference of these two is 5. Right? So this is for the main matrix. Then for matrix 1, please, let's look at this matrix 1. This is what you call determinant 1. Okay, this is called determinant 1. In determinant 1, we are going to do it like this. In determinant 1, we are going to replace these two. We'll remove these two from here and use this 1 and -2 to replace it. So we're now going to have 1 -2. Okay, in place of this 2 and 1, we now have 1 -2. Bring this constant, put it here. All right, then here it will remain 1 -3. All right, this is determinant 1. So determinant 1. Then we do the same thing. We are going to repeat the same thing for determinant 1. Okay, because we have used it to replace the first column For determinant 2, we'll use it to replace the second column. This determinant 1 will be used to find x, all right? While determinant 2 will be used to find y. So let's do the same thing. 1 times minus 3 is 1, open brackets, minus 3, which is 1 times this is 1, open bracket, minus 3. Then here we have minus, the natural minus, when multiplying across. Then here we have minus 2. Okay, so we are going to have minus 2. Then times minus 1. So we have minus 1. You can see here, we have 3 minus. We have 3 minus. We have minus here. Then the two numbers also have minus. So what it means is that here we have usual multiplication, which is minus 3 here. Okay? But we have minus here and we have plus here. So 1 times 3 is 3. Then minus remains here, because there's nothing to change in minus to plus. Then this is minus times plus. Okay, this is minus. Let's just put minus here. Let this minus be here. Then this minus times this minus is plus. All right. Then 2 times 1 is 2. 2 times 1 is 2. All right. Then we are going to have this. When we multiply these two, when we add these two together, what are we going to get? We'll get minus 5. We'll get minus 5 here. You can see, all right? Just take a look at this. So from here, you can see that the value of x will be 1, right? Yes, the value of x will be 1. So if you solve this thing, you are going to get the value of x to be 1, right, from here. So you can project your answers. Then let's go to the second determinant. The second determinant is determinant 2. This will be used to find y. Okay, so to get this, let's put our sign for our determinant. Now, in this case, you see, what you remember in determinant 1, we used this constant here, 1 and minus 2, to replace the first column, 2 and 1. Instead of having 2 and 1 here, we now have the first column, 1 and minus 2. 1 and minus 2, right? But in determinant 2, we are not going to do that. What we are going to have is this. We are going to retain 2 and 1. We are going to retain this 2 and 1 here. That is 2 and 1. We are going to retain the 2 and 1. Then it is the second one that will be replaced. Okay? We are going to replace this second column with this constant. So here is now going to be 1 and minus 2. 1 and minus 2. So this is how we are doing it for determinant 2. For determinant 1, you remember this 1 and minus 2 are here. You can see it now. But for determinant 2, it will be in the second column. Okay, this constant will be in the second column. Now we can go ahead and cross, as in cross multiply across. So we start with this one, which is 2, open bracket, minus 2. Yeah, that's what we're going to do. This is 2, open bracket, minus 2. Then our natural minus will appear, definitely appear, please. It's the first thing that will be written here once we are done multiplying first. Okay, then that's what will be written here. Then 1 times 1 is the next phase here. 1 times 1. All right? That is 1 times this 1. Then if we go ahead, our 2 times 2 is 4. 2 times 2 is 4. Then there is a minus here. Please don't forget that. We are going to put a minus here. All right? Then here we have minus again. 1 times 1 is 1. 1 times 1 is 1. And when we add up these two, remember the two of them are negatives. Don't forget, adding two negative numbers will give you negative. Look at it. Adding two negative numbers will give you negative. It's only when we are multiplying that it changes to plus, okay? But when we are adding negative numbers, we must arrive at negative numbers, okay? It's like when you are borrowing money, you still go and borrow again. You are going to keep owing. So this is minus 5. Can you see minus 5, minus 5, minus 5? So it means that the answers for x and y are 1, okay? X will be 1, y will be 1. Look at them here. They are evidence here. Now, how do I get my, how do we get our x? Okay, our x is going to be theta divided by theta 1. Okay, theta divided by theta 1. So, and that gives us minus 5. Theta is minus 5 divided by theta 1. Look at, sorry, not delta 1 rather. Okay, delta 1 is minus 5 too. So we write minus 5. And that gives us 1. Our x is 1. Then what is our y? Same thing. Okay, it's as simple as the first one. So our y is going to be theta again, theta. But this time it will be divided by delta 2, please, delta 2. And that gives us minus 5. Okay, because delta is minus 5. Look at it here. Delta is minus 5. Then divided by delta 2 is also minus 5. Look at minus 5 here. And that gives us 1. Okay, so that's what we are going to get. So it means that our x is 1 and our y is equal to 1. So we can therefore write that x equals to 1 and y equals to 1. This is the matrix method of solving simultaneous equation. If you do not want to go through the usual method, you can use this method. It is quite easy. Just replace it. It is called the determinant method. All right, it's called the determinant method. The determinant method helps us to determine the values of the variables in a system of equations by replacing each row with the constants. Okay, that's exactly how it is done. So thank you very much for coming. Welcome to AZ Science TV. This is a channel where you come and learn how to solve mathematical problems, mathematical questions live. All right, this is a live stream. We want to bring mathematics closer to you. We want to make maths fun. As you enjoy mathematics, you are learning. So these are our plans. Okay, so these are the reasons why we don't want to skip any step. So I hope you are deriving value in my video. If you are doing that, if you are getting any value at all in my video and you have not subscribed, please do well to smash the subscribe button if you are joining for the first time. Then as for my subscribers that have been coming regularly to watch our stream, we appreciate you for that. And our videos that are already online, I hope we are all watching it. Thank you very much for joining me. I appreciate you for joining me. So this is Good Morning Mathematics. It's a show that takes place every morning. Please also do well to join us tomorrow by from 9 to 10 o'clock. It's a 2-hour class tomorrow. Tomorrow's class is filled with fun, okay, and excitement. So please do well to join us tomorrow. We'll have a 2 straight hour class, okay, and it is tagged Mathematical Weekend. So always join us, all right? I will also enjoy you to put some comments below the comment section. So thank you very much. For those that are just joining us, let me repeat what I've done so far. This is 2 by 2 matrix. So it's the simplest matrix. Okay, it's 2 by 2 matrix. So here we are given a system of equations. Okay, in this system of equations, this is equation 1. We can tag this equation 1 and tag this equation 2. All right, so tag 1, equation 1, 2. Normally, we are supposed to solve them using the usual method, right, of either elimination method. You either use elimination method or we use substitution method. But here we are using the matrix method, which is the determinant method here. All right, that's what we're using now. There are other methods of matrices, but this is the determinant method. Remember, we dealt with determinants yesterday also. So that's why we're dealing with determinant method here. So what you do here, we extract the coefficients. Here, 2. The coefficient here is 2, so we'll have 2 here. Here, it is 1, okay? Coefficient here is 1, but we usually do not write it, okay? We usually do not write the coefficient 1. So we have to bring it here to show that it exists here, okay? That's what it means. Then here we have minus 1. So here, there is a 1 here, so minus 1. That's why I have minus 1 here. And here we have minus 3, so that is the minus 3 we wrote here. Then we are going to place our x and y here. The unknowns, the variables will be here, the unknown variables. Then equals to this constant here will be written here. So this is how to arrange this simultaneous equation, the system of equations. So this is how we put it, right? Now, what we'll do first is to find the determinant of this matrix, okay, that we got from the coefficients here. So when we find the determinant, this is how to write the determinant. Delta, determinant is delta equals to 2, 1, 2, 1, then minus 1 and minus 3. Minus 1 and minus 3. Remember, these are two lines. These lines here are not these ones. These are the brackets showing the matrices. But this is showing us determinant. It means we have to find the determinant of the elements inside this space, all right, between the two lines. So to do that here, we are going to multiply 2 by minus 3. That's what we got here, 2 times minus 3. Then minus. This minus is the natural minus that comes when we are multiplying across. Okay, 2 times minus 3, that's 2 times minus 3. Then minus 1, this is the 1 here, minus 1 times minus 1, okay? This minus 1 is this minus 1. Then this 1 is this 1. Then this minus is the normal minus that comes with the matrix, okay? This is the matrix minus, don't forget that. So here, 2 times 3 is 6. I know we have minus here, and here we have plus. So plus times minus is minus here. Then minus times minus here. Remember, this is times, so it will change to plus. Then 1 times 1 is 1, and that is equals to minus 5 when the two are combined together. Always give the sign of the bigger number. Always give the sign of the bigger number to the answer. Then take the difference here and plot it here. Just put it here, right? Then that is for theta 1. Then for theta 2, replace this, okay? Use this one to replace this first column. Use the constant here to replace this first column. That is for theta 2. That's what we're going to have here. So instead of having 2, 1 here, we now have 1 minus 2. Look at it, 1 minus 2. I'll be used to replace this, to replace 2 and 1. So we now have 1 minus 2. That's what we are now going to use to find delta 1. Okay, delta 1. So delta 1 will now be this. So we can do the same thing we did here. Okay, 1 times minus 3. That's 1 times minus 3. Then this is the matrix minus. And then open bracket, minus 2 times minus 1. Minus 2 times minus 1. All right? So if we do that, 1 times minus 3 is minus 3. Then minus here, this is a minus. Then minus 2 times minus 1 is 2. Because minus times minus is plus. Then 2 times 1 is 2. So that's why we have 2 here. This minus is this minus here. Don't forget that. Then we'll combine these two, we'll get minus 5. That is for theta, and that's for delta 1. Then for delta 2, we are not going to replace this one for delta 2. Okay? Remember, for delta 1, we replaced it with 1 and minus 3. For delta 2, we will now come here and do the replacement. We'll take out this one and use this to replace it for delta 2. So delta 2, 2, 1 remains 2, 1 here. Then we'll now use this 1 and minus 2 to replace it here. So that's why we have 1 here and minus 2. So cross multiplying, we have 2 open brackets minus 2. That is 2 times minus 2. Then minus 1 times 1. That's 1 times 1 here. Right? So 2 times 2 here is 4. And the minus remains here. Then minus 1 times 1 is 1. So when we combine it, we'll get minus 5. Right? We'll get minus 5. Then, once we have gotten all these values, the next thing is for us to get our x. Okay? We are going to use delta 1 to divide delta to get our x. So that's what we did here. So here we have x equals delta. This is delta, which is minus 5. Okay? Then divided by delta 1, which is minus 5. That gives us 1 here. Then y equals delta, which is still minus 5 here, divided by delta 2. Delta 2 is also minus 5. So that's what we got. We got 1. So the implication here is that our x equals to 1 and our y is equals to 1. So thank you very much for watching. We are going to look at the 3 by 3 matrix in the evening, when we come in the evening. Please don't forget our class on Saturday, online bumper packing.